Before we can talk about high performance in Node.js, we need to understand what Node.js actually is, because there's a common misconception. Node.js is not a language. It's a platform built on top of V8, Google's open source JavaScript engine. V8 is the same engine that runs JavaScript inside Chrome. It implements ECMAScript, which is actually a fairly simple and very flexible language on its own. But here's the thing: vanilla JavaScript, the language itself, has no way to access the network, no way to read or write from the disk, no way to talk to other processes. It cannot even stop its own execution. It has no exit instruction. JavaScript, by itself, is just a scripting language trapped inside a sandbox. Node.js fixes this by exposing a non-blocking I/O model using libov, a high-performance, cross-platform library for asynchronous I/O. This non-blocking API is what allows your Node.js code to access the file system, connect to network services, and execute child processes. On top of this, the Node.js API adds two other critical elements: buffers and streams. Because JavaScript strings are Unicode friendly, buffers were introduced to handle binary data raw bytes that don't fit neatly into a string. Streams are built on top of event emitters and provide a unified interface for reading and writing data. You'll find streams and buffers everywhere in the API, reading file contents, receiving network packets, piping data between processes. Together, V8 plus libov plus buffers and streams give you a platform that is intentionally simple, intentionally small, and designed from day one to be fast. Performance is a precise concept. It is the amount of work completed in a defined period of time, using a defined set of resources. That definition matters because it anchors performance to specific, measurable goals. The performance goal for your application might be low latency, responding to requests quickly. It might be low memory footprint, keeping your RAM usage small. It might be reduced processor usage, running efficiently without burning CPU cycles. Or it might even be reduced power consumption, which matters a lot in embedded and mobile contexts. To understand how well your application is actually meeting these goals, you perform performance analysis. The act of performance analysis has a formal name: profiling. Profiling can be done in two ways. You can instrument the source code directly, adding probes and counters that track exactly what the code is doing at runtime. Or you can instrument a running instance of the application, measuring its behavior from the outside as it runs. Instrumenting the source helps developers spot common performance weak spots during development. Instrumenting a running instance lets you test across different environments, different load conditions, and different hardware setups. This second kind of instrumentation is what we call benchmarking. Now, here is something important about Node.js specifically. Node.js is known for being fast, but that statement needs unpacking. Node.js is not that fast in the sense of raw computation, it's just as fast as your resources allow. What Node.js excels at is not blocking your application because of an I/O task. In most languages, when a disk operation happens, the entire thread stalls. In Node.js, that doesn't happen. Your application keeps running. Other tasks keep executing. The platform signals you when the I/O is done. This non-blocking model is what makes the perception of performance so different in Node.js compared to other platforms. Once an application goes into production, performance analysis becomes even more important, not less. Users are far more demanding than you were during development. They don't accept anything that takes more than a second. And the behavior of your application under real production load, over time, across many concurrent users, is something you simply cannot fully replicate in a dev environment. Monitoring is how you watch your application in production. It means observing the application's behavior over time, under specific loads, and surfacing the data you need to understand where your platform is failing or where it will fail next. Here's an important mindset shift: your application will fail. The question is not if, but when. So the goal of monitoring is not to prevent all failure, it's to be prepared. Create a backup plan. Have fallback hardware. Build service probes. Anticipate failure scenarios before they happen. When you set up monitoring, here are the key things to watch. First, application level metrics: requests per second, concurrent connections, error rate, exception percentage per request. Your application emits errors and throws exceptions in production. That's normal. What's not normal is ignoring them. Second, infrastructure level metrics: your server's power supply stability, disk speed and capacity, server room temperature. Temperature degrades hardware performance over time. A server that overheats is a server that slows down and eventually fails. Third, choose your disks wisely. Faster disks cost more and usually come in smaller sizes. Sometimes the trade-off is worth it. Speed matters more than storage. Don't just measure gigabytes per dollar. Measure gigabits per second per dollar. Monitoring is what transforms your application from something that runs to something that you understand.